Okay, in this unit, we're going to recap how to solve equations. In your warm-up, we gave you basic two-step equations, so let's talk about how to solve them. An equation has to have an equal sign, which you see. In order to solve it, you're wanting to get the variable by itself. So in both of these, the variable is the letter x. And in order to get it by itself, we have to undo the operations that we see. So first thing I'm going to do is I'm going to box in my 2x. I have to get that 2x by itself, which means I need to move the 6 away from it. Since the 6 is a positive, we're going to subtract 6 from both sides. My 2x drops down. My equal sign drops down. I'm going to type that in my calculator. 10 minus 6 is 4. I am not done because, again, I want the x 100% by itself, and right now that 2 is attached. When that 2 is attached like that, that's saying multiplication. Opposite of multiplication is division, so I'm going to divide each side by 2. My 2's cancel. I have to divide 4 by 2, so x is 2. We can always take this answer and plug it back in where we see that x to make sure it comes out okay. And I'm going to do that in my calculator. So the very first thing I see is 2. We said x was 2 and they're multiplying, and I can add 6. I get 10. 10 is what I see here. On our next one, again, x is still my number. I'm going to box it in so I know what I have to move first. I have to move this plus 5, so I'm going to subtract 5 from both sides. My 3x drops down. My equal sign drops down. I'm going to subtract 17 minus 5, which gives me a 12. Again, 3 and x are next to each other, which means we have to divide. My 3's cancel. There's my lonely x. 12 divided by 3 is 4. So now, there are two ways to simplify equations before solving. We can use the distributive property. We can also see combining like terms. And that's what you're going to see here today. So part 1 tells us simplify using the distributive property and then solve. So there's going to be an extra step first before we can get back to that warm-up. Distributive property involves multiplying a term to multiple terms within the parenthesis. So here's how I like to explain this. When we distribute something, I like to use cupcakes. We have to distribute to everyone. So it is not fair for me to distribute one cupcake to one person in this class and not give everyone else that cupcake. So in order to be fair, we have to distribute all of our cupcakes to everyone in this class. So in this example, the number that is being distributed is always the number attached on the outside of the parenthesis. I'm going to act like I'm the number 3. And I'm passing out cupcakes. When I do this, I have to take my number 3 and go see my friend X. I then have to take my number 3 and go see my friend 5. And it's still going to equal 45. Up here, it said distributive property involves multiplying, and you can see that with the parentheses next to each other. When we multiply 3 and x, it just becomes 3x. They go together. 3 times 5 is 15, and we get that 45 still on the other side. So now if you look, I am right back to where I was up here. So I'm going to box in that 3x because that's the guy I need to get by itself, which means I have to move this 15. Since it's positive, we're going to subtract 15 from both sides. My 3x drops down. My equal sign drops down. 45 minus 15 is 30. I'm now going to divide by 3 because that's the number with the x, and x equals 10. Again, I can take this number and plug it right back into this equation. So if I do that, there's a 3 first, a parenthesis. I'm going to put 10 instead of the x, plus 5, close my parenthesis. Oh, there's my 45, and 45 is what I wanted. Now, this first one I did the long way. We expanded. Okay, we don't have to expand every time. I like to call it my rainbow method. So I'm going to draw my line. This one's a little bit different. My parentheses is on the other side. That's fine. I'm going to drop my 10 down, equals. The number this time that I'm distributing is that 0.2. It's on the back side. Again, perfectly fine. I'm going to take that 0.2 and I'm going to distribute to my first friend out front. And that's going to give me a negative 0.8x. I'm going to go back to that friend 0.2 and I'm going to go to my second one, that negative 3. When I do that, I get a negative 0.6. I'm going to box in that x because that's what I have to get by itself. This one's a little bit different. This time that 0.6 is a negative. Opposite of a negative is going to be a positive. So we're going to add 0.6 to both sides. So we get 10.6 equals a negative 0.8x. Don't forget that negative has to drop down. I am still going to divide. I still divide by the number with my x. And when I do this, I get negative 13.25 equals x. If you look at my answers, they kind of look opposite. X was on the left here, x is on the right. It does not matter which one you're giving me. The reason x is on the right over here is because that's where it started. Okay, now this last one, again, my x is starting on the right-hand side, so I'm going to drop my 1.5. The tricky one on this one is you have fractions, and that's okay. So I'm going to go to my friend that's on the outside, and I'm going to distribute to that very first thing. Since it doesn't have a number with x, it's just a negative 5/4, and my x tags along. And then I'm going to go back to my outside friend, and I'm going to go to the second one. Guys, you have a calculator for a reason, so let's talk about fractions in our calculator and how to multiply. Very first thing, there is a negative in front. So negative 5, that big A, B / C is your fraction bar. I'm going to put a 4. Times, you can use the multiplication, you can use parentheses. There's another negative 6 fraction 5. And it tells me it's 1.5 or 1.5, and it's a positive. So you can keep it a fraction, you can change it a decimal. That is 100% up to you. Here is the x that I have to get by itself. So since this one is a positive 1.5, I'm going to subtract 1.5. Double check. In my calculator, those will cancel. I have to have a number there, and that number is 0. And that's okay. 0 is a number. It's on a number line. It's on a graph. Perfectly fine. I'm going to keep going because x is technically not by itself. I am now going to divide by a negative 5/4. Again, we can type this in our calculator. 0 divided by a negative 5 fraction 4, and it tells me my answer is 0. So 0 equals x, or x equals 0. It does not matter. 0 is a number, guys. You have to get that through your head. It can be an answer. A lot of times people will stop, and we can't do that. Okay, on my next part, it says simplifying by combining like terms and then solve. So combining like terms means adding or subtracting terms that are alike. So if you look at this first box, it says practice finding like terms. So it says put a box around any term that is like 3x. So when we look for like terms, we look for a similar variable, so the same variable, and those variables have to have an exponent. So on this one, my 3 has a singular x. There is no exponent, so that's exactly what I'm looking for. It tells me to box them. So 4x is alike, 6x is alike, 7x squared is not because of that squared. My negative x is alike, 9 is not, 6 is not, 11x to the 4th is not, negative 7, 0.75x, x squared is not because you're squared, y is not even the same letter, 2xy, it does have the x, but then it has this additional y, so it's not alike, 25z, negative 4/5, and then your 1/8 x. So there are all of the like terms to 3x. Now it says to circle the ones that look like a 5. If you look, 5 doesn't have any letter. So I need all of the things that are not letters. They have to be a number. So if I look, 9 is a plain number, 6 is a plain number, negative 7 is a plain number, and a fraction, negative 4/15 is a plain number. Okay, so those are like terms. So if we wanted to, we could add and subtract all of those in our calculator and come up with a final answer when we simplify. But they have to be alike. So I'm going to draw my line again. I go left to right. You can highlight, underline, box, circle, just like we did. It's up to you. So I have this friend right here. We need to be careful because there has to be a number. It is an understood 1, so I'm just going to put a 1 in front so that way we know we're going to add or subtract something. I also have a negative 4x. So right now you can't type your x in the calculator, but you can type those numbers. 1 minus 4 is a negative 3, and your x drops down. We then have to drop down that plus 10 because it's still hanging out, and it equals a negative 2. Now that we've combined like terms, we're back to our warm-up. Here is the friend that we need to get by itself. I need to get rid of this positive 10, so I'm going to subtract 10. Negative 3x equals a negative 12. Again, calculator, if you struggle, divide by that negative 3. My x is now by itself. Negative and negative make a positive. 12 divided by 3 is 4. Again, this one looks funny because the 6 is by itself on the left, and that's fine. Again, I'm going to go through and look for my like term. My like terms are directly next to each other. So before I do anything else, that 6 that's right behind the equal sign, I'm going to drop down. 3 minus 7 is a negative 4x. I now have to get this x by itself. This one's tricky. This is a positive x. Even though we don't see a plus sign, it is positive. So opposite of a positive is a negative. So I'm going to subtract the 6 from both sides. Again, they cancel. I have to have a number there, so it is 0, and it equals a negative 4x. I'm going to divide by that negative 4 because you always divide by the number with the variable, and x equals 0. Again, you can put 0 equals x. This is a habit. I'm surprised on the top ones I didn't flip it around. Okay, here's this next one. I'm going to go through and combine my like terms. I have a plain negative 5, and I have a plain 10. So negative 5 plus 10 is going to be 5. Be careful, that is a plus 14. If you look at my box, I kind of covered that up. And it equals a negative 79. I have to get that plus 14x by itself. Again, this is a tricky one. This 5 has to go away. It is a positive 5 because we don't see a sign in front. Opposite of a positive is a negative, so I'm going to subtract 5 from each side. 14x equals a negative 784. I'm going to divide by my 14, and we get a negative 6. X equals a negative 6. Okay, on the back side of our notes, let me flip it over, guys. This is where the application comes in. So you have 2 word problems and you have 2 shapes. So let's talk about these. It says, write an equation that represents the following situation. Mrs. Polly and Miss Adams went to Rally's to buy food. They bought 2 hamburgers and an order of mozzarella sticks, which cost $2.50. The total cost of their order was $15.25. Write the equation to find the cost of each hamburger. So here's the thing that I do. I always look for a total. They tell us the total is $15.25. I like to have my total on the right-hand side, so I put that first. Then we have to ask ourselves, what are we getting? It says 2 hamburgers. Well, they don't tell us how much those hamburgers are, So I'm going to say 2x, x is my hamburger. But they also tell me I'm getting 1 mozzarella stick, so I have to add the $2.50 to my purchase as well. So again, from here, I can get my x by itself by subtracting my $2.50 from each side. So I get 2x equals $12.75. I can divide by 2, which means each burger is going to be $6.38. Now this next one, I'm just going to practice writing, and then you guys can solve. I will give you the answer if you're wanting to check your answer. So Zeke and Crosby went bowling. Zeke played 2 games and spent $5 on food. Crosby played 4 games. If they spent a total of $20, how much money did they pay for each game? So let's start with Zeke. Zeke played 2 games and he spent $5. I know spending sometimes gives you that negative thought, but we're looking at a total here. And when we do a total, we're adding all those pieces. It then says Crosby then played 4 games. And they told me my grand total is $20. So on this one, we would combine like terms. You guys can try it out. In the end, your games are going to cost $2.50. Okay, these next two. On these next two, these are big ones. You have seen some of these words before, but it says if the area, does not say that. If the perimeter of a trapezoid is 149, find the value of x. So here's the thing. Any shape, it does not matter if it's a trapezoid, a square, a rectangle, a triangle, it can have 100 sides. The perimeter means to add all the sides. Add them. So right now we know the total is 149. I'm going to start adding. I have 2x. I have plus 3x minus 2. I have another plus 2x. And finally, I have plus 5x plus 7. Now, this is when we can go through and combine all of our like terms. So I'm going to look for all my x's first. 2x and 3x makes 5. Plus 2 is 7. Plus 5 is 12x. I then have these numbers. I have a negative 2 and a positive 7, so that's going to give me a plus 5. And it still equals 149. From here, I need to get that 12x by itself. So I'm going to subtract 5 from each side. 12x equals 144. Divide by 12, so x equals 12. Now this next one, they still want perimeter, but it's a little bit tricky. They tell you that the perimeter of a square is 152 inches. Find x. You have to use what you know about a square. What we know about a square is every single side is exactly the same. So there are multiple ways that we can do this. We can do this with combined like terms because we can go back to what we did over here. We could also say, since there are 4 sides and each side is 3x minus 7, we can multiply them. And those 2 pieces are going to give us a grand total of 152. So now this, the way that I set it up, is the distributive property. 4 times 3 is 12x. 4 times a negative 7 is a negative 28, and it equals 152. I have to get my 12x by itself. This time, there's a minus. Opposite of subtraction is addition. So 12x equals 180. And I'm going to divide by 12 to get a final answer of 15.